Every day you go through the same process. Wake up from a good night's rest and go to school. But as you know, this is not as simple as it sounds. There are many steps involved, right from waking up to taking a shower, to eating breakfast, to commuting to school.
This is something you know, but did you know that this mechanism of going to school has a deep connection to chemistry? What is that? Meet me in the studio to find out. Hi, I am Deobrata Goswami. Welcome to the logical world of chemistry. Today, we will unravel the mechanism behind chemical reactions.
In today's episode, we will study reaction mechanisms, homolytic and heterolytic cleavage by which the reactions take place, and then we will look at reaction intermediates like free radicals, carbocations and carbanions. And finally, we will discuss some important questions and their answers in Exam Decoded.
Nearly all reactions occur not in a single step but in a series of steps. Reaction mechanism helps in understanding what changes are taking place at each step while reactants are converted into products. So what is a reaction mechanism? Well, consider the process of you going to school.
So, you sleeping in your bed is the reactant, and the desired end result, at least by your parents and teachers, is to have you in school. But jokes aside, it's not as simple as it sounds. There are many steps in this reaction. A. You wake up. B. You take a shower. C. Have breakfast. And D. Go to school.
I'm sure you got that. So let's translate this into chemistry. Take a look at how chemists believe hydrogen and iodine react to form hydrogen iodide. So, a chemical reaction is a series of changes by which substances react with each other to form new substances. The formula equation we write for a reaction is the sum of all the steps in a reaction. But the overall reaction does not tell us how the reaction is actually proceeding. That is, what is the mechanism of the reaction. Now, why do we need to know this mechanism?
Well, study of the reaction mechanism helps in understanding the changes taking place at each step of a particular reaction. It also helps in understanding the reactivity of compounds. Further, knowing reaction mechanisms can help us in the synthesis of new compounds.
Let me explain with the help of an example. What happens when methane and chlorine react in the presence of light?
Take a look at the reaction on your screen. You may think, does the transformation of methane to methyl chloride involve one step or several? If so, what are these steps? What is the function of light in the reaction?
The answers to all these questions can be found by understanding the reaction mechanism. Reaction mechanism can be defined as the sequential account of each step describing details of electron movement, energetics during bond cleavage and bond formation, and the rates of transformation of reactants into products. Now, let's go back to the process of you going to school. If you remember, you were sleeping. So we can say you were the substrate. But you may have continued to sleep unless someone woke you up.
In short, as a substrate, you need an attacking reagent to begin the process.
Now, let's translate this into organic chemistry.
An organic reaction is believed to take place by the attack of the reagent on an organic molecule. This molecule is also called substrate. This leads to the formation of a number of intermediates. These intermediates finally lead to the formation of products and byproducts.
Just as our journey from one station to another includes various intermediate stations, a reactant's journey to reach its product also encounters various intermediates. One thumb rule you must always remember is, when a reaction takes place, that is, when reactants form products, the bonds in the reactants will be cleaved first. This process is known as bond fission.
A covalent bond can get cleaved by either of these two ways: homolytic cleavage or heterolytic cleavage.
But knowing the names is not enough. So, let us first study homolytic cleavage in detail.
In this type of cleavage, when the covalent bond breaks, each atom gets one electron each from the shared pair of electrons.
Whenever homolytic cleavage takes place, it leads to the formation of neutral species with an unpaired electron. These species are called free radicals. Free radicals are denoted by putting a dot over the symbol of their atom or group of atoms.
Let us understand homolytic cleavage more clearly with the help of an example. In the presence of UV light, chlorine molecule undergoes homolytic cleavage to form free radicals of chlorine. An important point to remember here is that homolytic fission is denoted by the fishhook shaped half arrows. These arrows are used to show the movement of single unpaired electron.
Since homolytic cleavage results in the formation of free radicals, therefore organic reactions which proceed by homolytic cleavage are also called free radical reactions. Before we move further, let's take a break, but I will leave you with something to keep your gray cells going. Which scientist is said to be the founder of radical chemistry? If you want more information and questions on this topic, you can log on to www.topperlearning.com. And to know the correct answer to the question, join me after the break. Welcome back. I am Devabrata Goswami and today we are discussing reaction mechanism. Before the break, I had asked you to identify the scientist who is said to be the founder of radical chemistry. And the answer is Moses Gomberg.
In 1900, Moses Gomberg reported the generation of the first organic free radical, the triphenyl methyl radical. The radical was formed by reacting triphenyl chloromethane with silver metal in benzene. He is therefore known as the founder of radical chemistry.
Now, coming back to free radicals. As we discussed earlier, free radicals are species containing an unpaired electron. If the unpaired electron is on carbon atom, then they are called alkyl free radicals. Alkyl free radicals can be classified as primary, secondary and tertiary depending on the class of the carbon atom carrying the unpaired electron. Let's talk some more about them. A primary free radical is the one in which an unpaired electron is present on the primary carbon. Recall that primary carbon is that carbon which is bonded to only one carbon. A secondary free radical is one in which the unpaired electron is present on the secondary carbon. A secondary carbon is that carbon which is bonded to two carbons. A tertiary free radical is the one in which the unpaired electron is present on the tertiary carbon. As you know, a tertiary carbon is that carbon which is bonded to three carbons. As far as the stability of alkyl radicals is concerned, tertiary free radicals are more stable than secondary free radicals, which are in turn more stable than primary free radicals. After studying homolytic cleavage and free radicals, let us now move on to heterolytic cleavage. In this type of cleavage, the covalent bond breaks in such a way that one of the fragments takes both the electrons of the shared pair, leaving none on the other. Heterolytic cleavage is unsymmetrical and results in the formation of two charged particles. Do you know what the species produced during heterolytic cleavage called? Carbocations and carbanions are formed during heterolytic cleavage. Well, the species are called carbocations if they have a carbon atom possessing a positive charge. Carbocations are electron deficient because they have only 6 electrons in their valence shell. Let us now study the classification of carbocations. Carbocations can be classified as primary, secondary and tertiary depending upon whether 1, 2 or 3 carbons are directly attached to the positively charged carbon. Ethyl carbocation is a primary carbocation. Isopropyl carbocation is a secondary carbocation and tertiary butyl carbocation is a tertiary carbocation. It's time to take up a question from one of our viewers.
Hello sir, I'm Arvin and I have some doubts regarding carbocations. Can you please explain the stability of different carbocations?
I am glad you asked me that question. As we know, carbocations are electron deficient species. When groups like the alkyl group, which have electron donating inductive effect, are present, they release electron density towards the positively charged carbon atom. This stabilizes the carbocation. Therefore, more the number of alkyl groups, the greater will be the stability of the carbocation. Therefore, the tertiary carbocation is more stable than a secondary carbocation, which in turn is more stable than a primary carbocation. To understand it better, let's see this example. Which of these carbocations is more stable? Now, we know that a tertiary carbocation is more stable than a primary carbocation. We can see that the first structure represents a primary carbocation and the second structure represents a tertiary carbocation. Therefore, the second carbocation, that is tertiary, is more stable than the first one, that is a primary carbocation. But what happens if during heterolytic cleavage the species formed contains a carbon atom possessing a negative charge? Well, such species are called carbanions. Carbanions may be defined as a group of atoms that contain a carbon atom bearing a negative charge. Like carbocations, carbanions are also classified as primary, secondary and tertiary depending on whether 1, 2 or 3 carbon atoms are attached to the carbon bearing negative charge. In general, primary, secondary and tertiary carbanions are represented as shown. The alkyl groups may be same or different. Now, just as different carbocations vary in their stability, carbanions also vary in their stability. Order of stability of carbanions can again be explained on the basis of electron releasing inductive effect of alkyl groups. Greater the number of alkyl groups on the carbon bearing negative charge, greater would be the electron density released by the alkyl groups. So, the negative charge on carbanion gets intensified, making the carbanion more unstable. Therefore, the primary carbanion is more stable than secondary carbanion, which is more stable than tertiary carbanion. That's all the theory for today. I hope this lesson has given you clarity on reaction mechanisms. It's time now for a short break. Stay tuned because coming up next is Exam Decoded. Welcome to Chemistry 11. I am Deobrato and we are exploring the world of chemical reactions. Before stepping ahead onto our next segment, let's do a quick recap of today's topic. In today's episode, we studied that the sequential account of each step taking place in a reaction is referred to as the reaction mechanism. The reaction mechanism describes details of electron movement and energetics during bond cleavage and bond formation. A covalent bond can get cleaved by either homolytic cleavage or heterolytic cleavage. Free radicals are formed during homolytic cleavage and carbocations and carbanions are formed during heterolytic cleavage. I hope now you are ready to get tested. So, let's move on to Exam Decoded. Welcome to Exam Decoded, that much awaited segment of our episode where I will give you lots of tips and advice to help you become a topper. So, let's get on to our rapid fire round. I will ask you 5 questions and you have to answer them quickly in not more than 5 seconds. Here is the first question for you. The detailed step-by-step description of a chemical reaction is called A. Reaction mechanism, B. Isomerism, C. Catenation, D. Hybridization. The correct answer is A. It's called reaction mechanism. Second question. Which one of the following represents an example of carbocation? A. CH3+, B. CH4, C. CH3CH2-, D. C2H6. The correct answer is A. Next, which is the most stable carbocation? A. Tertiary, B. Primary, C. Secondary, D. Methyl carbocation. If you chose A, you are right. Just 2 more to go. Heterolytic cleavage results in the formation of free radicals. True or false? It is definitely false, as heterolytic cleavage produces carbocations and carbanions. The last question. Free radicals contain an unpaired electron. True or false? This is true. Now, let's see how you scored. If you got all 5 questions right, we will call you a high flyer. You did well. This shows that your concepts are quite clear. If you got 4 or 3 right, then you are an achiever, and a little more study can get you on the top. But if you got 3 or less, you need to go through the topic once more. For more help on this topic, you can always log on to www.topperlearning.com, where you will find all that we studied today and a lot of questions for practice. So, what role does this topic play in your exams? Well, this topic, reaction mechanism, comes under the unit organic chemistry and carries a weightage of 7 marks. This makes it critical from exam point of view. The questions asked from this topic can be very short answer type questions for 1 mark and short answer type questions for 2 or 3 marks. These would typically test your knowledge ability and conceptual ability. Let us now see how to answer one such question in order to get full marks. The question is, explain what are free radicals. Give one example each of a primary, secondary and tertiary free radical. Also, mention the order of stability of free radicals. This question carries 3 marks. Let me show how you can score 3 on 3 if this question comes in your exams. Begin by explaining that free radicals are an atom or group of atoms which contains an unpaired electron. They are formed during homolytic cleavage. This definition will fetch you half mark. Ethyl radical, isopropyl radical and tertiary butyl radical are examples of primary, secondary and tertiary free radicals respectively. Mentioning examples of each category along with proper classification will fetch you half mark each. As for the stability of free radicals, tertiary free radical is more stable than secondary free radical, which is more stable than primary radical. Mentioning the correct order of stability of free radicals will fetch you another 1 mark. Well, I hope you got that. If you didn't, you can always log on to www.topperlearning.com. So you see the connection between your going to school and chemistry. All processes follow a step-by-step mechanism. It's now time to say goodbye. But don't worry, I will leave you with some food for thought. Did you know that free radicals affect the aging process? How does a very common antioxidant like vitamin C help in reducing the aging process? Oxidation reactions can produce free radicals, which start chain reactions that damage cells. Antioxidants like vitamin C terminate these chain reactions by removing free radical intermediates and inhibit other oxidation reactions by getting oxidized themselves. Just one benefit of knowing the reaction mechanism. Keep thinking. Till next time, this is Devabrata wishing you all the best. Goodbye.